So as we are solving our inequalities today using multiplication and division, we absolutely have to keep in mind that when we're using our inverse operations of multiplication and division to solve, if we multiply or divide by, and the reason I circled that is because the number that you're multiplying by or dividing by, that's the number that's important. Not what it's happening to. What are you doing it by? If you are multiplying or dividing by a negative number, you have to reverse the direction of the inequality symbol. Now, there's one time already that we reversed the direction of the inequality symbol, and when is that? What's the one time we do it right now already? Can anybody think of a time that maybe we have already reversed the symbol and we weren't doing this multiplying or dividing by a negative? How about this statement? 3 is greater than x. Is there anybody that likes that named differently?
Some people like the x is less than 2.
Yeah, some people like it with the x on the other side, don't they? So when we want the x on the other side, when we want the x and the 3 to trade places, what do we have to do with the sign? We have to flip it. So here we're reversing it for a different reason though. So we have to keep both thought processes in mind. Sometimes we reverse the symbol because we're renaming it. We like the name with the variable on the other side, so we reverse it to rename it. Other times, it's because we're multiplying or dividing by a negative number, okay? So this was just a little review here of what's the one time we already reversed it. Okay, so let's start some practicing here. We have negative 3x is less than 27. What would we do to get x alone in this one?
Divide the 3 both sides.
Divide both sides
By 3.
by
Negative 3.
negative 3. See, that's why it's so important for you guys to say the correct terminology. We're going to be dividing by a negative 3. When we divide by a negative, as we're bringing things down, what do we have to do? Do we need to reverse our symbol?
No.
Did we divide by a negative?
Oh, yeah.
We divided by a negative, so we're going to reverse the symbol. And what's 27 divided by negative 3?
Negative 9.
Negative 9. Okay. I want you to put a little side note over here. Divided by a negative. So, sign reversed. Okay? That little note. You don't have to do that every time in your homework, but at least have that here so you can say, when you look at it, you can understand why did it start out pointing to the left and now it's pointing to the right. Okay, solve, we just did the solving, and graph. So now we do our number line graph. So this is our solution, algebraic solution, and now we'll make our number line graph. Integer neighbor to the left,
Negative 10.
negative 10. Equidistant away from it to the right,
Negative 8.
negative 8. Our circle goes at the negative 9. Is negative 9 part of the solution set? Okay, how do we show that it is not part of the solution set? Don't shade it in. Okay, what should we shade then? What is the solution set? Where are the numbers that are a solution? Is negative 10 a solution? No. Is negative 8 a solution? Yeah? Okay, then we should shade this way, huh? So we'll ask ourselves, is negative 8 greater than negative 9? Okay, but we have to do one more. Let's just do one more quick question also. Ask ourselves this one. If I put -8 back up in here. That one that I said, you know what, it is part of the solution region along with a whole bunch of other numbers like -8.5, -8 9/10, -2, 0, 1 million. There's a whole bunch of solutions. But if I just take one of them, if I take -8 and put it back up into the original up here, what's -3 times -8? What is that?
24.
24. Is 24 less than 27? Okay, it is, isn't it? It's got to make the original statement true. Okay, along with making this one true, it has to make that one true also. If we had put -10 in there, let's say we had shaded going the other direction. We forgot to reverse our symbol. Let's say we forgot to reverse our symbol, and we shaded the other way, and we said -10 was in the solution region. What's -3 times -10?
30.
30. So now we have 30 is less than 27. True? No. So it wouldn't have made it true. It's not a solution. So because we remembered to reverse the symbol like we were supposed to, we ended up with the correct shaded region. Okay? Okay, let's look at number 2. What would we do in number 2?
Divide the 1.5.
Okay, we don't divide the 1.5. What do? Divide both sides by 1.5. Divide both sides by 1.5. -6 is going to get divided by 1.5. And there's an equal to bar here, don't miss it. And 1.5x is going to get divided by 1.5. Okay? The 1.5s on the right side cancel each other out. What's a negative divided by a positive? Negative. How many $1.50 are there in $6? Let's figure it out. $1.50 plus another $1.50 is $3, and then another $1.50 is $4.50, and then another $1.50 is 6. So there's 4 of them, and they are negative, aren't they? Should we reverse our symbol? We have to stop every time today and ask ourselves that question. Should I reverse the symbol? Why not? Did we divide by a negative?
No.
Remember we said we're dividing by a 1.5 and it's not negative, so we do not reverse our symbol this time. We leave it going the direction it was. But do you like it named this way? Some of you get by with leaving it named this way. Others of us need to rename it so the variable's on the left. So can we reverse it to rename it? Yeah. So if we want to rename it, let's put if renamed, then that symbol has to change. Only because we're renaming it now. And now we can probably get a better graph that way. Because some of us like to shade whatever way the arrow's pointing. But we can only do that when the variable's on the left. Integer neighbor, I always like to start with the left. What's the integer neighbor to the left? -5. To the right? -3. Circle at -4. Is -4 part of the solution set?
Yeah.
Okay, what do we do then? Shade it in. Okay, how about -5? Is it part of the solution set?
Yeah.
Is -5 less than -4?
Yes.
Yeah. Okay, let's test out -3 just to be sure. Is -3 less than -4? No, so I'm thinking that, yeah, we should probably go this direction, right? So notice, when the variable's on the left, it's saying the shaded part, X is the shaded part. The shaded part should be going to the left. That's kind of what that says. But only when the variable's on the left can our brain do it like that. Up here, if we don't rename it, we cannot shade the direction that it's going. Okay? So, questions on either of these before we try another type? Because this one's got some fraction in it and what does X over 6 really mean? What operation is going on? Division. It's really x divided by 6, isn't it? So how do we undo dividing? Multiply by the same number that's being divided by, right? Okay, so we're going to take negative 1/3 and x divided by 6 and write it out again. Instead of trying to cram it in that line like I already know you're doing, stop. Take the time to write it again, and now we're going to multiply both sides by 6. Over here it would be convenient to put it over 1 because there's a fraction there. Over here it would be convenient to put it over 1 because there's a fraction there. What can we do over here? We're taking a fraction times a fraction. Is there like a, we can simplify it before we multiply, can't we? Adam, do you have a question?
No, I was about to give you the answer for the 6 over 1 times.
Here's what we're going to do. We're going to say 3 goes into itself how many times?
2.
3 goes into itself how many times? Once. How many times does it go into 6? 2. Okay. Once you have just ones downstairs, you can ignore them. And you can say, I got a 2 times 1 upstairs, which is 2. And I got a positive times a negative, which is a negative. Okay. Do we need brain stop? And should I reverse the symbol? What question are you going to ask yourself? Did you multiply or divide by a negative? Did we? No, we multiplied by a positive, didn't we? Positive 6. So we do not need to reverse the symbol. Over here, these 6's cancel each other out. There's just a 1 down there. We have an x. But again, now our variable is not on the friendly side, the left side. So if we want to rename it to get a better graph, now we reverse the symbol for renaming it. And then we can graph it. So go ahead and graph it. You know, you've been doing it long enough that I don't really think we have to talk through it. And we'll see if we agree in the end. Okay, any questions on it? Okay, so there's 2 really important things you got to make sure that your brain says every time you do these problems. Did I multiply or divide by? Right there, you got to say that word by a negative. And then if you did, you're going to stop and say, I got to reverse the symbol then, right? Okay, let's look at number 4. What's that? What does negative x mean? What's happening to the x on that side? What does a negative in front of x mean? What operation's actually happening to that x? Because it's just not a positive x. Is it subtraction? No. It's kind of tricky. Here's what they do. This has been what we call cleaned up. Yeah, they just took that 1 out of there. So let's rewrite it with our 1 there. We have a negative 1x, which means x is,
Less.
no, meaning x is what's happening to it. It's
You
being,
can divide the
it's being multiplied by
1.
negative 1. It's being multiplied by negative 1. Okay, so when it's being multiplied by something, we undo that, we divide by that same thing. So we are dividing both sides by a negative 1. Do not go to your calculators. I won't hurt you. No, I really won't, but I want to. You use your calculator. What's going to happen here? These guys are going to cancel and we're going to have x. Do I reverse the symbol?
Yeah.
Yes, because we divided by a negative. A negative divided by a negative is a positive. 14 divided by 1 is 14. We do not need a calculator for that problem. Stop. In the name of calculator abuse, do not use it when you don't need to. Okay, do we need to rename this one? No need to. Let's go ahead and get it graphed. Okay, everybody got what I have? We all agree? Are these positive numbers or negative numbers?
Positive.
Positives. All of the solutions that are positive numbers. Any number greater than 14 is a solution to this. Okay, let's go to the back side. Today, when I go to the back side, keep putting in new pages instead of. Let's need to calibrate. Okay. Oh, two fractions in this problem, along with the x. So in this one, x is being
Times.
multiplied times by what?
2/3.
2/3. Anybody remember how we undo multiplying by a fraction? No, we don't divide. We can, but sometimes it doesn't work very well. What do we multiply by to undo a fraction? Multiply by its reciprocal. So we're going to multiply both sides, and we're not going to do it up here. We're not going to cram it in up here. We're going to write this problem down again. Come on. And then we're going to multiply on each side. We'll add a multiplication dot and multiply by the reciprocal of 2/3. What is that? 3 halves, 3 over 2. Both sides get multiplied by 3 over 2. Good news is 3's cancel, 2's cancel on this side. The x is by itself now. Question before we move on. You say to yourself, what? Did I multiply by a negative? No. So then what does that mean? Stay with the way it is, right? Okay. What's a negative times a positive? Let's decide that right away.
Negative.
A negative. Can those 3's cancel out upstairs?
No.
No, because they're both on the same floor. How about the 2 and the 4? Can we do anything with them? No. Is there anything we can do before we multiply it? I don't think so. So what's 3 times 3? 9. 4 times 2? 8. Well, it sure would be nice to know where negative 9/8 is on the number line. Let's give it its fixed number name, okay? So we're going to say that is really x is greater than or equal to a negative, what mixed number is 9/8? 1 and 1/8. There's going to be our solution, because then when we graph it, we have a better idea of what that graph should look like. Now, this time, before you make that first tick mark, before you even make it, what two neighbors that are integers are on either side of this negative 1 and 1/8?
Negative 2 and 0.
Negative 1 going that way and negative 2. Let's do this then. Let's just do this. This actually makes it a little bit easier. Because now what you'll decide is, which one does it live closer to? Negative 1. It should be, so we have to visualize that this would be divided into 8 equal sections. So we only want one of those away from negative 1. So this would be about half. So I'm thinking about right there. Would be negative 1 and 1/8. Put my circle there. Should we shade it in?
Yeah.
Okay. What direction should we shade? In the direction of neighbor negative 1 or in the direction of neighbor negative 2?
Negative 1.
Negative 1. Okay. Okay. And our very last problem. you're going to sometimes have to set up your own inequality statement. So for number 6, it says 7 is no less than the quotient of x and 3. So I'm thinking that we got to know what inequality symbol we should use for is no less than. And we also need to know what operation's going on here, and I'm thinking the word quotient will help us with that. So what do you think we should put? Let's just take the 7 and let's write that down first of all. 7 is, or 7. And then we have this is no less than. Greater than or equal to the quotient of x and 3.
7 plus 3.
Quotient.
Oh.
Sum is adding.
X times 3.
Division, so it would be x over 3. X divided by 3. Let's write it as like that other problem we had that was x divided by 6, remember? Okay, so now we've got it set up. Now what are we going to do to solve this? Well, we're going to write it down again because I see a fraction, and as soon as I see a fraction, I know I'm going to have to do some multiplying off to the sides. And what are we going to multiply by?
Just 3.
What's x being divided by? 3. Don't mess with that x. Leave it alone. It wants you to get rid of the 3. Multiply both sides by the 3. 3 times 7 is? 21. Did we multiply by a negative?
No.
No. So we're not going to reverse the symbol. Over here, these guys are gone. That was the goal. We either leave it like this because we understand how to graph it, or we rename it as what? X is less than or equal to 21. Okay? And then, even if it doesn't tell you to graph it, we always graph it. Just don't even think about it. As soon as you write that algebraic solution, you go about graphing it. This becomes a part of the problem every time. Okay. Questions? Okay, then let's get out a sheet of loose leaf paper.